All right, guys, and problem number 7 on this worksheet was the first one of 2 asking you to deal with a radical function, and we hadn't done one like that yet, so let's dive in. So they've called their function y, so our derivative then is going to be dy dx, and that is going to be here a limit as h approaches 0 of, and here we go, f of x plus h is the original function, but everywhere there's an x, we're going to replace that with an x plus h. So we get the square root of x plus h, and then a plus 2 after that. So that takes care of the f of x plus h minus f of x, the original function, unchanged, is just the square root of x plus 2 all over h. Okay, so that's where we're at right now. And in every one of these problems that we've done so far, it has involved some form of algebraic manipulation to eventually get this problematic h in the denominator to cancel out. Now, same kind of thing is going to happen here, but we're going to have to be a little bit more creative on how to do it. And this actually harkens back to a skill that we talked about in Chapter 2. To get rid of this big binomial expression in the numerator, we are going to multiply both the top and the bottom of this fraction by the conjugate of that numerator. So that's going to have the same first term, square root of x plus h plus 2, but then instead of a minus square root of x plus 2, we're going to have a plus here, the square root of x plus 2. Got it. And then down on the bottom, we of course have to multiply by the exact same thing, square root of x plus h plus 2, and then again plus the square root of x plus 2. So we're multiplying by the conjugate on both the top and the bottom right here, the conjugate of the numerator. Okay, so here we go, guys. What's that going to do for us? This will now equal the limit as h approaches 0 of, and let's see what happens here. The numerator is where interesting things should happen. So we're multiplying 2 conjugates. The first product is going to be this term here times this term here. Well, the square roots are just going to cancel, and we're going to get x plus h plus 2. All right, the outer and the inner products are going to cancel each other out. And then at the end, it's going to be a minus, and then the quantity here, x plus 2. That's what we get from multiplying the square root of x plus 2 times another square root of x plus 2. In the denominator, we've got h times this big messy binomial here. I don't think there's any point to distributing that h, so I'm going to leave it there, times the square root of x plus h plus 2 plus a square root of x plus 2. Now, did we actually accomplish anything? I think we did. Let's see if we can do this in our heads, guys. We're going to distribute that negative right here, so that's actually a minus x minus 2, and then what we were hoping would happen, happened. Plus x, and remember this is a minus x after you distribute, plus 2, and then this is a minus 2 after you distribute. So the only term remaining in the numerator is that h, which cancels out with this h in the denominator, of course leaving behind just a 1 in the numerator. And since the h in the denominator was the whole problem to begin with, I think we're now okay to do direct substitution. So let's see where we're at, guys. I'm going to, let's go ahead and put the 0 in there. So my numerator is just a 1. And then what do we have here, guys? The square root of x plus, that h becomes a 0 now, plus 2. So x plus 0 plus 2 is just x plus 2, plus another square root of x plus 2. And we can clean that up just a little bit to make that 1 over, and anything plus itself is 2 times that same repeated addend right there. So there it is, guys. 1 over 2 times the square root of x plus 2 is the derivative then of the square root of x plus 2. And later on in this chapter, we're going to learn a little rule called actually not really the chain rule, it's really a power rule problem now that I think about it, that'll kind of verify that result. But this is how you would get it using the definition of the derivative.